Hi, my name is Dara. Today I have prepared for you another SwiftUI app crash course. In this course, we will be building an expense tracker app. This app is inspired by Mint, a free tool to track your spending, income, bills, and budget all in one place. You can also view all of your account balances and network. What's awesome is that since it connects to your banks, you don't have to enter any transaction entries manually. I use it every day for managing my personal finances, and it has been great. Recently, Mint has been putting a lot of efforts into revamping their app. They really brought it up a notch. As for our personal finance app, the main view features a chart that tracks this month's spending as of date. If we drag over the chart line, we can see the history of total spending per specific day. Below, it displays the most recent 5 transactions that occurred. Each transaction details the merchant, category, date, and amount. The amount is negative if it's a debit or positive and colored if it's a credit. On the left, we can see the icon associated to the category. These icons are loaded from a third-party library and mapped through each category. If you click on the See All link, we are redirected to the All Transactions screen where they're grouped by month. Back to the home screen, there's a notification bell icon in multicolor variant in the navigation bar. This app also offers a beautiful dark mode. Beware that this app is data-focused. As it is a financial app, we will be performing calculations and apply various logics to resolve the right data. Let's get started. Alright, let's create a new Xcode project. The template is iOS app. Next. Name it Expense Tracker. The organization identifier is your domain in reverse. Let the interface be SwiftUI and the language Swift. Next. Save it in the folder that you want. Create. Make this full screen, close the right panel, and choose the simulator device iPhone 13. Resume and adjust the screen size of the canvas. This app, like any real app, has its own color system. It will cater to both light and dark modes. Let's set that up. Go to the Assets folder and create a new folder named Colors for organizing all of our color sets. The color name will be given by its usage. Add 3 new color sets for background, icon, and text. Open the Inspectors panel and make sure to be on the last tab, Attributes Inspector. We'll define each color by a hex value. I went online to get some colors and settled on different blue tones from FatUIColorPicker.com. Blue means trust and reliability, so it fits with the concept of our app. Starting with background, select the Any Appearance color card for the light mode. Make sure the content is sRGB and select 8-bit hexadecimal as the input method. The color I chose is Alice Blue for the background. So here I can copy the hex color and paste it here. For the dark mode, select the dark color card and repeat the same steps. The hex color is going to be this one. For icon and text, there will only be one single color for both color themes. Therefore, in the Appearances drop-down, select None. The icon hex color will have this value, and for the text, this is the hex value. Now we can close the inspector panel, as well as the Assets tab. Next, we will create an extension to color to easier retrieve these custom colors and to avoid typo at the same time. Create a new Swift file. Call extensions. Make an extension to color. Xcode complains that it cannot find type color in scope, so let's import SwiftUI. Next, declare static constants for the 3 colors from earlier. Static let background equal, and initialize color with the name of the color set. Let's do the same for the icon. Then the text. While we're here, we'll also add system background from UI color. Here though, initialize color with the UI color argument dot system background. We'll be needing it later. Close extensions. In content view, replace the text view with a navigation view. Set its modifier navigation view style to stack. Inside the navigation view, let's add a scroll view. We're going to apply a background color to the scroll view to color.background. Easy this way, right? Finally, set the navigation bar title display mode to inline. Next, let's add the notification bell on the right side of the navigation bar. To do so, add the toolbar modifier. Enter. As usual, we'll add a marker for each UI element for reference. Then, insert a toolbar item. The item is an image from FS symbol, whose system name is bell badge. The symbol has a multicolor variant. You can see it by selecting multicolor. And we can activate that by adding the modifier rendering mode to original. However, oftentimes the default colors are not what we want. We can specify our own colors with setting the symbol rendering mode to palette instead, and the foreground style to color.icon, and primary, since there are 2 colors. Let's place the title in. Inside the scroll view, create a V-stack with leading alignment, spacing of 24. We'll make sure to wrap the content inside the padding. We'll mark this as the title. For the title, add a text view that says Overview. Set the font to Title 2 and make it bold. By default, the scroll view takes the size of its largest child. To make the whole screen scrollable, set the frame of the V-stack max width to infinity. Since we'll be taking care of both color themes, it's best to show the both of them in the preview for testing. On the canvas, click the Add Preview button, and it will automatically reflect in the code. There are now two instances of content view wrapped in group. To the second one, click on the Preview settings, and under Color Schemes, select Dark. Heads up, we will be doing this for every new view in the future. Coming up, we'll set up the data model for the transaction as well as compose test data for the previews. Then we'll move on to design the view for the transaction rule. We'll program many extension methods in order to display information in the correct format, such as date formatter and string to date converter. Finally, we'll install an icon library and use their icons to identify the category, which will add a nice touch to the UI. First things first, let's shape a data model for the transaction. Create a new Swift file. Name it Transaction Model. We'll declare a struct for transaction and make it conform to identifiable since it contains a property ID. That way, we'll be able to easily loop the transactions in the list because each entry has to be unique. Define the model like so. We have ID, date, institution, account, merchant, amount, type, category ID, category is pending, is transfer, is expense, and is edited. The properties declared with a let is read only, and the ones with var are editable. Note that type follows the transaction type's raw value. In other words, its string version. Now let's create an enum for the transaction type. It's going to return a string. There are only two cases for it, either a debit or a credit. Case debit and case credit. Following the model, we can set up some initial data that we can use to display in the previews only without calling any API. If the intent of the data is for mocking only, then it's important to arrange them in the preview content folder. In fact, any file under it won't be included in the production build, thus reducing the bundle size. So under that folder, create a new Swift file called preview data. Then declare a variable transaction preview data equal transaction and initialize it like this. This is the first entry from the API that we'll be calling later on. In addition, we'll do the same for the list. Var transaction list preview data. But here we don't want to take too much time mapping out each transaction. A tip is to repeat a data type as how many times as you want and make an array out of it. I'll show you how. Initialize an array of transaction with repeating and count, repeating the transaction preview data, and I'll set the count to 10. Now that we have the transaction model and preview data ready, it's time to build the view. Create a new SwiftUI file under Content View. Name it Transaction Row. It takes a prop transaction of type transaction. The first layer of the body is an H stack with a spacing of 20. And we're going to apply a top and bottom padding so that each row has enough spacing between them. Padding, add an array with top and bottom, comma, it. Fix the preview by adding the transaction prop by clicking on Fix from the recommended solution. The value for the transaction will be transaction preview data. Resume. Here again, add another preview for the dark mode. To the second preview, set the preferred color scheme to dark. There you go. We'll first place the merchant info inside the H stack, add a V stack, with alignment leading, spacing of 6. Enter. For the content, add a text view. For the transaction.merchant, so the marker is the transaction merchant. Make the font subheadline in bold and set the line limit to 1. Right under this, we'll insert the category info. Add another text view for the transaction.category. Set the font to footnote. The opacity to 0.7. And same here, the line limit to 1. Finally, under the same column, we're going to place the transaction date. Add another text view. We'll put the current date for now because the transaction date is a string, therefore not in the desired format. We'll need to convert it to a date format first before being able to use it. The text view only accepts a string, so let's turn the date into a string by adding the format property and calling .datetime .year .month .day. Their default formats are exactly what we want. Again, make the font footnote and set the foreground color to secondary. For parsing a string date to a Swift date, we'll need to program some helper methods. In the extensions file, we're going to extend date formatter, declare the static method, static let all numeric USA, because our string dates format is commonly used in America. This is of type date formatter equal. Start by initializing a new date formatter. Let formatter is equal to date formatter and assign its date format property to be the receiving format. Formatter dot date format equal dt YYYY. Then return the formatter and call the method directly, like so. This is a lazy method, and make sure we initialize dateFormatter once only, as dateFormatters are expensive operations. Also, static helps to ensure there's only one instance of it. We can prove that by logging this method. Here, print, initializing dateFormatter. Afterwards, make another extension, but to string this time, and add a method dateParse that takes no arguments and will return a date. The parse date will call from the all-numeric USA method from dateFormatter, followed by the date method from the value is from self. Since there's a possibility that this fails, we'll guard this line, guard, and we'll return today if that happens. Otherwise, return parse date. Then we can establish a computed property for the transaction date in the transaction model by calling this method var date parse of type date, and we'll return date.dateParse. Now we're able to use it in the transaction row. Go to transaction row. Instead of the current date, the value is going to be transaction.dateParse. Resume. We'll put the transaction amount in another column to the right. Under the VStack, place a text view for the transaction.amount, formatted to currency with code USD. Ideally, the currency code should be dynamic, taking from the transaction itself. We'll set the font bold and the foreground color depending on the transaction type. So transaction type equal transaction type dot credit dot raw value. So if it's a credit, we'll choose color dot text, one of our custom colors. If it's a debit, we'll choose primary instead. Let's add a spacer between these two columns, shall we? Logically, though, we should show a negative amount if it's a debit, right? Into transaction model, we're going to add another computed property for signed amount. It's a double. We're going to return and check for the type of transaction. Is the transaction type credit dot raw value? We're going to return the amount unchanged. And if not, we're going to return the amount, but with the negative sign in front of it. Now we can replace the amount by signed amount in the transaction row. Resume. I saved the hardest one for last, the category icon. We're going to place it on top of the VStack. Insert a rounded rectangle with corner radius 20 and the style continuous. The fill color will be the custom icon color with opacity 0.3. And we're going to set the frame width to 44, the height to 44 also. No alignment. It's just missing the icon now. We will resort to a third-party library instead of going through the trouble of downloading icon assets into the project. I decided to go along with the SwiftUIFontIcon library for this app. It was appealing to me that it offers icons from Material Icon, Eon Icons, if I say that right, and Font Awesome. And it seems very simple to use. If you scroll down, there are instructions on how to install this library via the Swift Package Manager. Back to Xcode. To add the library, go to File menu and Add Packages. Then in the package URL field, enter the address of the Git repo. As per instruction, select branch as the dependency rule and set it to master. Add package. Again. Note that if you are on Xcode version 13.2, you may have trouble resolving packages. So update to the latest version, which is 13.2.1 at the time of recording. This is what happened to me. Close. To be able to access icons from this library, import SwiftUIFontIcon. Then add an overlay to the rounded rectangle with content and call FontIcon.text with the font code, font size, and color. The font code, we're going to take it from Awesome 5 Solid. And let's put as icons for now. The font size is 24 and the color is color.icon. It's cool that we don't have to type the icon name, isn't it? We will only be using icons from Fonts Awesome free library. We have completed the implementation of the transaction row, but before being able to display it in a list, we need to fetch multiple transaction data so we can feed them to the list. We will set up a class that will manage the call to the API via combine and save the return data into a state property to be read throughout our app. This class will follow the view model pattern in the sense that it will manage the presentation logic of the view and will also relay between the view and the model. Let's begin by creating a new Swift file under Transaction Row. Name it Transaction List View Model. Then create a final class of the same name. This class will conform to observable object. Observable object is part of the combined framework that turns any object into a publisher and will notify its subscribers of its state changes so they can refresh their views. Inside it, declare a publish variable, transactions. Its type is an array of transaction. And initialize an empty array as the default value. The property wrapper @publish is responsible for sending notifications to the subscribers whenever its value has changed. Following that, let's add a method for fetching transactions from the network. Fun get transactions. In this situation, a data URL is required. To simplify things and speed up the process, I made up a list of mock transactions in a JSON file and hosted on designcode.io. If you look into the data carefully, you notice that our transaction model defined previously matches the data model here. Back to transaction list view model, and inside the function, declare a constant URL and instantiate URL with the string as the data URL. We need to check if this URL is valid or not with a guard statement. If not, we'll print an invalid URL message for us and exit the function with return. To fetch data from an API in Swift, it demands an URL session data task. URL session dot share dot data task. However, let's take advantage of the dataTaskPublisher from Combine instead. This one. The URL is going to be our URL here. I much prefer it to the regular data task as it allows us to combine events together via operators and handle the response and data in each step of the way. Besides, it's simpler to code, easier to read and understand. Then we try to map the response. As opposed to map, tryMap enables us to throw an error. If that happens, it would end the stream with a failure completion. In the closure, we're provided with the data and response tuple. And it should return a data type. A tuple is a pair of values grouped into a single one and is recognized by parentheses separated by a comma. After that, we guard if there's a response. Guard let HTTP response equals response, and we're going to typecast it as HTTP URL response. And if there's a response, verify its status code at the same time. HTTP response dot status code equal 200, else. Note that here we only validate if the status code is 200 because the URL is a JSON file. But a more complex API may return between 200 to 300 non-inclusive for a success. So you may want to take that into account. If those two conditions fail, let's dump the response. Dump response. Dump is like print but in a more readable format, good for logging objects. Then we're gonna throw a URL error with the error code batch server response. If there's no error, we're going to return the data. After we get the data, we should decode it into a data model, which is an array of transactions. .self. We'll use JSON decoder as our decoder, well, since our data is in JSON form. Now, this requires that our data model is decodable. Therefore, as recommended, we're going to make transaction conform to the decodable protocol. Go to transaction model and add decodable here. We make sure to receive the data on the main thread as it will perform updates on the UI. Receive on dispatch queue dot main and remove options. The next step is to process the data with the sync operator. It supplies two closures: the receive completion for handling the success or failure cases, and the receive value for handling the output. Here, enter completion in. We'll use the switch statement to go through the completion cases. Switch completion. If the completion event is a failure case, case.failure, let error will print error fetching transactions and the error's localized description. If it's a finish case, we'll say that it's finish. Print finish fetching transaction. What do we want to do with the output result? We'll store it in our transactions array. Self.transactions equal to result. Additionally, we would want to insert weak self in front of result in order to create a weak reference to self. This prevents memory leaks as it can release self from memory when necessary. Now result becomes an optional, so let's add an integration mark after self. For testing, let's dump the return transactions temporarily. Dump self.transactions. Since sync conforms to the cancelable protocol, meaning it supports cancellation and returns any cancelable, the final step is to store the cancelable reference to the subscriber in a set of cancelables. When that reference gets deallocated, it will cancel the subscription, thus free up resources. It's a similar concept to when you decide to cancel a subscription from the App Store. You go to your device subscription management screen where Apple lists all of your active subscriptions so you know which one to cancel. The only difference is that the sync and store process does it automatically upon the deinitialization of the subscriber, for example, a view. I hope this is a good example. Let's go ahead and create the cancelables variable. But first, we need to import combine. It is only at this step that we need it. Actually, instead of importing SwiftUI, import combine instead. Here, declare a private variable, cancelables, and initialize it to be a set of any cancelable. Alright, this wraps up our fetch function. Now we just need to figure out when to call it. Let's do that when this class is initialized. Add an init method and call getTransactions. Furthermore, we want to initialize the view model when the app launches, which is in Expense Tracker app. var transaction list VM equal transaction list view model initialize. On top of that, mark it with the StateObject property wrapper so that it can follow the lifecycle of the app. At the same time, SwiftUI will reserve a memory for it in the environment. A rule we need to abide to is to add the EnvironmentObject modifier to the view or scene, in this case, content view, for which you plan to allow any of its child views to access that EnvironmentObject. EnvironmentObject, and pass in transaction list VM. At last, we're ready to run the app and see what's logged in the console. Press Command R to run the app. As mentioned earlier, there's nothing on the main screen yet. Let's look in the debug area. Go to the top. Don't worry about these warning messages. If you run the app in a real device, they won't appear. This is the fetch transactions. If you scroll down a bit more, this is the result of the dump transactions. Now that you've seen how the received data looks like, we can delete the dump transactions line of code. Later on, we'll be able to view them directly on the UI. Once the data is fetched, we're apt to inject them into our views. Precisely, we'll implement the design of the recent transactions card. Additionally, the icon that was previously attached to the transaction row was fixed, so we'll need to turn them dynamic by mapping each transaction category with a specific icon. Let's create a new SwiftUI file on the content view. Name recent transaction list. Resume. Start with the VStack, then an HStack, and for the header title, a text view that says recent transactions. Make it bold. To the right of the header, add a navigation link with destination and label. Leave the link view empty for the moment as it is not ready yet. The label is going to be an HStack with a spacing of 4. And inside it, a text view for see all and an image with system name chevron.right. Apply the foreground color to the HStack as the custom text color. Next, insert a spacer between the title and the link to push them to the corner. As well, add a top padding to the outer HStack for it's too close to the top border. Let's format the container for this view. First, add a padding to the VStack. And for the background color, choose system.background. Then clip shape the card with a shape of rounded rectangle with corner radius of 20 and style continuous. Finally, add a shadow whose color is primary with opacity of 0.2, radius 10, x 0, y 5. Following that, we will prepare to feed data in. Remember that we have an array of transactions stored in transaction list view model. And that view model was also saved in the environment object. Well, we can retrieve the environment object with the property wrapper at environment object when declaring an instance variable for that view model. Here, at environment object var transaction list VM, transaction list view model. Due to the fact that we just tagged the property without giving it a default value, the preview that calls the recent transaction list will crash later on when we loop the transactions as it's missing that parameter. Here though, we can't proceed the same manner as in transaction row because it's a view model and on top of that, without an argument. We'll need to inject the preview data differently. Here, declare a lazy static constant, static, let transaction list VM of type transaction list view model. Inside this closure, we'll initialize an instance of transaction list view model. Let transaction list VM equal transaction list view model. Then we'll push the transaction list preview data to its transactions property. Finally, we'll return that instance. Then we'll initialize the static constant. This is a trick to enforce a different value to the view model for the preview. You've seen this before in this project. It's similar to date formatter. Don't forget to pass the static transaction list VM as EnvironmentObject to the preview since it's a separate entity from the app. As usual, add a second preview for the doc theme. Move this below, remove this line, and set the preferred color scheme to dark. At last, time to show the list of transactions. We're going to do that here. Let's loop the transactions with for each from the transaction list view model. Transaction in. And call the transaction row for each one with the parameter as the local variable transaction. Let's run the preview so we can see clearly each row. We said we were only going to display the most recent 5 transactions. So by calling the prefix method, it'll return the initial specified number of elements of a collection, in our case, 5. Let's add a divider between each row to separate them clearly. Note that here, we're not using SwiftUI's list view since it's a card with titles in it, or else it's going to look weird. As you can see, the last transaction row also shows a divider, but it shouldn't be there. We'll need the index from the array too, and if it's the last one, hide the divider. We can append the enumerated method, which will return a pair of counter and element of the collection. Here, add enumerated. Consequently, we'll need to make a new array out of the original one. So array and wrap all of this inside it. This new sequence requires an ID, so let's use the element itself. Now we can join the index in the closure. One more thing, there's this error message to fix. Generic struct for each requires that transaction conform to hashable. Just go to transaction model and make transaction conform to hashable. That's it. Next, let's add an opacity to the divider and only render it invisible if the index is 4. So if the index, is it equal to 4? If so, make it 0, else 1. Resume. Voila! Notice that all the icons are the same. That's because earlier in transaction row, we set a prefixed icon from FontAwesome code. We'll take care of this immediately. Go back to transaction model and declare a new struct for category. We're going to add properties for ID, name, icon, and main category ID. Let ID in, let name string, let icon. It's of type FontAwesome code, so we need to import SwiftUIFontIcon in this file. Import SwiftUIFontIcon. The main category ID is optional, so it has to be declared with var instead of let. Var main category ID int with the question mark. Next, add an extension to category in which we'll create an instance of category for each possible transaction category and assign it to a static constant, like so. Don't worry, I'll include all of this in the written content or description so you can just copy and paste. The ones on top are the main categories, whereas the ones at the bottom are the subcategories. Therefore, they contain an extra argument main category ID that associates them together. Take notice that the subcategory's ID number follows the main category's ID number. This practice can provide a clue to whoever works in this project as to which subcategory belongs to which category. Let's create another extension to category to organize these individual categories into main categories and subcategories. Extension category. These are the categories, and these are the subcategories. The advantage of doing this way is that we can retrieve one or the other easily. We can then combine them into a single array named all. Static let all of type category array equal categories plus subcategories. After setting up all the categories and assigning each one of them the proper icon, we can get the icon for the transaction according to its category. Guess how? That's right, by adding another computed property to the transaction model. In there, declare a variable icon of type FontAwesome code. Let category equal. We'll retrieve the first category returned from category.all where the element's ID is equal to category ID. It's possible that there's no category that satisfies this condition. Mind, that would be a mistake in the data. So let's apply an optional binding control flow with iflet. If a category is found, we'll return the category.icon. If not, we'll return the question icon, for example. Now we can make use of this icon property in transaction row. Go to transaction row. Instead of icons, it should be transaction.icon. Resume. Let's check how the icons look like in recent transaction lists. Not bad. On a side note, the reasoning behind adding all the computed properties directly in the data model is due to the fact that I wasn't planning to create a view model for an independent transaction, such as transaction view model. The view model wasn't necessary as there's nothing to fetch and no functions to involve. On the other hand, if they were for your project, you may decide to put them in the view model instead. Finally, the recent transaction list is ready to be displayed on the main screen. In Content View, place it right underneath the title. Recent transaction list. Alright. The side effect of adding recent transaction list in here is that it crashes the preview, as you can see. The reason being that recent transaction list is a child of Content View and is dependent on the EnvironmentObject. Therefore, we're also required to pass an instance of transaction list view model in the EnvironmentObject to the preview. Just copy and paste the approach we took from recent transaction list. Copy. Paste. And add the modifier EnvironmentObject, transaction list VM. Resume. There you go. Let's see the dark mode. Beautiful. Coming along, we'll implement the screen that shows all the transactions separated by month. This is February, and this is January. As well, we'll enable the navigation to that screen from the recent transaction list. Let's kick off with the prep work. The data we want to present in the new view is sectioned by the month and a list of transactions within that month. Essentially, we can store that kind of data into a dictionary. A dictionary is a set of key-value pairs, and the key would be the month, whereas the value is the transactions. Back to Xcode. In Swift, it's a smart practice to create a type alias for a data type in order to make it reusable and easy to refer to. Go to Transaction List View Model. At the top, declare a type alias transaction group for a dictionary of string and an array of transaction. For simplicity's sake, we'll create another computed property for the month. Go to Transaction Model, declare a variable for month. It's a string type and returns a value from dateParse formatted to datetime.year.month. And we want to show the full month as the title. Next, we'll need to manipulate the original transactions into the dictionary. Back to Transaction List View Model. Let's create a function group transaction by month that'll return our type alias transaction group. We should ensure that the transactions array is not empty before proceeding. Guard transactions is empty, not, or else will return an empty dictionary. To group the transactions by a common variable, there's an initializer for dictionary type. In this case, our custom transaction group. This one. This creates a new dictionary whose keys are the groupings returned by the given closure and whose values are arrays of the elements that returned each key. We're grouping transactions by its month, $0.month. We'll store this new dictionary into a constant group transactions. And we'll return it. Once the data is ready, we can go ahead and build that view. So create a new SwiftUI file. Name transaction list. Resume. Start with the vStack container. We'll add the navigation title for transaction with an S and set the navigation bar title display mode to inline. We don't want to forget to add the EnvironmentObject variable. Transaction list VM of type transaction list view model, since we'll need its transaction data. Let's take care of the preview as usual before we go any further. Add a second preview for dark mode. Resume. To be able to see the navigation title, it needs to be contained in a navigation view. So embed each transaction list in a navigation view. Embed navigation view. Now you can see the navigation title. Make this preview dark. Preferred color scheme, dark. Next, copy the static constant transaction list VM declaration block from either content view or recent transaction list. Copy and paste it here. Then pass it in the environment object to the group. Environment object, transaction list VM. The next step is to loop through each group of transactions. Add in a list view, and for each group of transactions returned by transaction list VM dot group transactions by month, we'll iterate over the month and transactions in. However, it says that it cannot convert value of type transaction group to expected argument type range of integers. To fix it, wrap the input data into an array and use the key as the ID. Let's format the list style to plain. We're going to divide the group of transactions into sections with the corresponding title, that is the month. Insert a section with content and header. For the header, we'll add a text view with the label month. As for the content, show the transaction entries for each month. We'll loop them with for each again. Transaction in and call transaction row for the transaction. Now there's this separator under the header and the section. Let's hide it with list section separator. And make it hidden. There you go, it's gone. Finally, we're ready to display the transaction list. Remember that we left the destination view of the navigation lane empty in recent transaction lists? Here? Well, that's what was reserved for this. Now add transaction list as the destination view. Let's test the navigation link. You can see that it's not working. That's because the recent transaction list preview doesn't contain a navigation view. You can add it here if you want, just like we did in transaction lists. I'll just go to content view and check it out in there. Sweet. Observe that the navigation backbar button is blue. It's taken from the accent color. An accent color is the system's or app's theme color and applies to views and controls. The default color is the system default, which is blue. It really doesn't fit our design. We can change it with the accent color modifier to the navigation view and set it to primary. But bear in mind that all its child views will also inherit this accent color. Let's test it out again. Now, the navigation backbar button became black instead of blue. I don't know if you have noticed a little issue about the section header yet, but if you navigate back and forth, the top transactions switches randomly between January and February. We need to keep this consistent to not make a fool of ourselves. To my understanding, dictionary is an unordered collection of key-value pairs. So how do we turn it into an ordered collection? Let's go back to our typealias transaction group in Transaction List View Model. Basically, another way to write a dictionary type is to stamp the word dictionary in front, followed by angle brackets, and remove the square brackets. Now, replace the columns by a comma. Then replace dictionary with ordered dictionary. As simple as that. This new dictionary will contain elements in the order they were originally inserted. However, Xcode complains that it cannot find type ordered dictionary in scope. In fact, ordered dictionary is only made available if you import collections or order collections alternatively from the Swift Collections package, which in turn just came out at WWDC 2021 and introduced in Swift 5.5 and Xcode 13. It's a new library that extends existing data structures such as DQ, order set, and ordered dictionary. This library is what's going to save us. Now, there's another error. It says no such module collections. We need to add the library. To do so, go to File menu, Add Packages. Under the Apple Swift Packages, select Swift Collections. Leave the dependency rule as up to next major version and enter the current version 1.0.2 at this moment present. I made sure to check the Swift package registry for the latest version. Click on Add Package. On the next screen, when asked to choose package products for Swift Collections, check Collections since I imported that one. Add Package. Now you can see the new library in the list of packages. Close this. The error should disappear now. Of course, we could have sorted the months, but that would take way more efforts. Also, it helps that the data from the API is already sorted by the most recent transactions, as it should be. If not, the result wouldn't be the same. Now go back to Content View and test it out again. Resume. Click on See All. February. Again, it's still February. And for the third time, it stays February. That's great. At this stage, we're getting closer to the finish line. We're about to introduce charts into our project as planned. In a few moments, we'll manipulate the transactions data again to extract the expenses only and showcase them in a line chart. We'll make sure it will look decent in both light and dark mode. This is going to be exciting. Are you ready? Charts are best for presenting data at a glance, especially when it's intensive like in our app. We'd want to alleviate our development efforts by integrating a third-party library. I went along with SwiftUICharts because it's a SwiftUI library, therefore we don't have to apply a workaround to convert from UIKit to SwiftUI. Also, their chart designs look pretty. Look at that. Especially the line chart. On top, it mentions that the version 2's beta is available. Since we're in development mode, we should always go with the latest version. Granted, there are some flaws which we'll definitely come across. Let's hope they will get fixed in the release. Click on the link How to install SwiftUI Chart View for instructions. I'll walk you through them. Let's go back to Xcode to add a dependency, but this time we'll go another way. Go to the project expense tracker. You can see all of the packages installed and their version being used in the Package Dependencies tab. Click on the plus button to add a new library. In the package URL field, enter the repo's URL address. This one. For the dependency rule, select exact version and enter 2.0.0-beta.2. Click on Add Package and select SwiftUICharts. Add Package again. There you go. Close this. Once the package installed, we're good to lay down charts in our views. There are examples documented from the link How to create your first chart in Pages. We'll follow this. In Content View, first import SwiftUICharts. Then we're going to position a line chart between the title and the transaction list. Line chart. Resume. The preview is not working just yet, as all charts need data input. However, our data is not ready. It requires a complex function to transform it, so we'll reserve it for last. We'll just copy the demo data from the GitHub repo for now. Paste it here, and pass it in the data method of the line chart. Resume. It's missing another factor before we can view the chart. We need to attach the chart style method as well, as mentioned here. So let's do that. For the style, initialize chart style with the background color of color.systemBackground and the foreground color as the color gradient of two colors. The first one is color.icon with an opacity of 0.4 and color.icon. Now the chart is revealed, but it looks weird. It obviously needs a frame. So set 1 with a height of 300. Much better. Because we padded the whole view, we should outline the border of the chart to sync with the transactions card below. The library provides the card view for that purpose. The card view is not included in the examples, but I digged around and discovered in the Chart View v2 demo of the same owner, app pair. Like this. So back to content view, embed line chart in a card view, and move down the modifiers to outside of it. Right now, the chart is pretty bare and clueless without a reference such as a legend or a label. In addition to the card view, they also show how to add a custom text with chart label. Above the line chart, insert a chart label. The text is going to be $900 for the moment. The type has the size of title. And let's skip the format for now. It's getting there, but if we check the dark preview, we can't even see the label and the background color is still white. This is the first issue we encounter. If we right-click on Card View and jump to Definition, we realize that the fill color of the rounded rectangle is white. That means it's not dynamic for dark mode. Let's try to fix that by adding a background color to the card view. Make it color.systemBackground. If we run the preview, you'll see that nothing much changed except for the corners only. We can also try to apply the background to both the chart and label. Cut this. But there's a white space in between. We don't want that. All that is due to the fact that the card view, it's wrapped in a Z stack. That's the second flaw. I believe that the layout of this body needs to be revised, though we can get around that. The solution I found is to embed them in a V stack. Add a V stack. close this and remove this background modifier. I'm gonna re-indent these lines. So the background color is applied to the whole VStack. Resume. There you go. The third problem is the white shadow color. However, there's nothing we can do about it. I tried many things, but in vain. We're done with formatting the chart. Let's handle the data. The line chart will show a history of cumulative total expenses per day within the current month. Go to Transaction List View Model. First and foremost, we should declare another type alias. Transaction prefix sum for an array of string and double tuple. The string represents the date, whereas the double, the amount. By the way, a prefix sum stands for a record of cumulative sums. This data type is actually taken from the data method. Right-click on data, jump to definition. It either requires an array of double or of the tuples that we defined just now. Go to Transaction List View Model, and at the bottom of the class, we'll create a method to accumulate the transactions. Func accumulate transaction. It'll return in the form of transaction prefix sum. Once more, we'll guard for a non-empty array of transactions. Guard transactions is not empty, else return an empty array. Let's print this function name to know when and how many times it'll get called. Print accumulate transactions. Next, we need to pull out all the days in the current month. We'll define today as February 17, 2022, and convert it to Swift date with date parse. Ideally, it should be the current date, like this, but my data is not for production and ends on February 16. Then we can get the date interval from calendar.current.date interval of the month that includes today. Print date interval as well. The reason I force unwrap date interval is because we're sure that this date exists and that we'll be able to pull the date interval for the month. In the next line, we'll declare two variables for storing totals during the calculation. The first one is sum of type double, defaulted to 0. The second one is the cumulative sum, defaulted to an empty transaction prefix sum. To clarify, the difference is that the sum is a single value and cumulative sum is a set of values. Then we can parse through each day in the date interval. The hitch is that the date interval includes seconds, minutes, and hours too. so we can't loop with the usual for in. With the help of stride, though, we can skip those unwanted time frames. We'll do it like this. For date in stride, from date interval dot start to today, we'll step by a day, which is equivalent to 60 seconds times 60 minutes times 24 hours. Close this. An error pop-ups that global function stride from to by requires that date conform to stridable. That's easy to resolve. Go to extensions and add an extension to date and make it conform to stridable. While we're here, I don't like the default date format returned by the formatted function. We can override it by creating a custom formatted method that will return a string and will apply the formatted method to cell with datetime dot year dot month dot day like before. We'll be using it for logging purposes later on. Back to the stride function. Begin with extracting the daily expenses. By filtering the transactions whose transaction date parse is equal to the date in the iteration and whose expense is equal to true. Then the daily total would be the sum of those filtered transactions amount. Let daily total equal daily expenses. We can sum them up using the reduce method. Reduce initial result to the next partial result. From 0, delete all this, and subtracting the sign amount on each iteration. The sign amount is negative, so subtracting will turn the total expenses into a positive amount. Next, we'll add the daily total to the sum. And then append cumulative sum, both the date formatted and that sum. We'll definitely print these variables to verify our calculation. Print date formatted, daily total, sum. At the end of the function, return cumulative sum. And we're done with the function. Seeing as though the data are taken care of, we can put them to use in the chart. Go to Content View. We'll need a reference to transaction list view model also. So declare an @EnvironmentObject var transaction lists VM of type transaction list view model. Then call accumulated transactions to get the real data. Here, let data equal transaction list VM dot accumulate transactions and pass it in the data method. We can comment out the demo data now. As for the chart label, the total expenses month to date is equal to the second value from the last tuple of the data. By that, I mean data dot last dot one. Let's check the error message. We're gonna fix it like this. Also, the last method returns an optional, therefore default it to 0 in any case. Now we can input that amount in the chart label instead of 900. Total expenses dot formatted to currency with code USD. Now that we called the accumulated transactions function with all of its print, we'll be able to inspect them in the console by running the app in the simulator. Command R. All right. Let's see the console. We can see that the date interval starts from February 1st to March 1st. And for every day, there's a log for the daily total and the sum. Notice that the sums include those trailing digits. Not sure why it does that. We can make it better by rounding them. In extensions, create another extension to double. We'll add a method rounded to 2 digits that will return the same type double. We're going to multiply self by 100, rounded, and finally divide back by 100. Then in transaction list view model, we can call this method to round the sum. Sum equal sum dot rounded to 2 digits. Run the app again. You can see those numbers are in double digits now. At this point, there are a few remaining adjustments we have to make to claim that we have completed the chart feature. First of all, the label shows $0 on first appearance. The reason is that in transaction list view model, the transactions are defaulted to an empty array. There's nothing wrong with that. Besides, it's a published variable. So the chart view should update when that variable gets filled with data. This is just another shortcoming of SwiftUICharts. As a matter of fact, if we examine further chart label, scroll down, the title gets stored in text to display on appear, which is what's shown in the text view. There's no on receive, no binding variable. They assume that we never want the input title to mutate, which is not always the case like our app. Go back to content view. To work around this, we can add a logic to check if the data is not empty before even displaying the chart. Here, if data is not empty, move everything inside it. Now run the app again. And you won't see the initial $0 anymore. Secondly, when we move the point along the line, the label becomes centered. At the time when we added an additional layer of VStack for styling purposes, we should have made its alignment leading. So let's do that. Here, alignment, leading. I think maybe it's also the combination of the extra spacer if the interaction is not in progress. Command R again. There you go. The last issue is when we drag the point again, the amount is not in 2 digits and missing a currency sign. Indeed, the default format is a 1-digit number as stated by this string. Thankfully, we have the option to specify the output format instead of that one. To change it to currency, set the format argument to $%.02F. Let's try again. Now everything makes sense and consistent. Let's scan everything else. Everything looks fine. Let's check the dark mode. Oh, nice. Finally, this marks the end of the implementation. Oof, that wasn't too easy, nor was it all smooth during the process. But we overcame all the troubles, namely bug fixes and data transformation, in order to present them appropriately in our chart and views. I hope you have discovered new or different concepts that could prove useful to you in the future. For instance, data fetching with combine, data handling and computation, the icon library, the SwiftUICharts library, and the Swift Collections package. Please don't forget to like and subscribe. We'd really appreciate it. That's going to help us prepare more content for you. Cheers!